Space, the final frontier. A realm so vast, so unknowable, that even our most powerful telescopes can only scratch its surface. But here's the real mystery. What lies beyond everything we can see? Beyond galaxies, stars, and cosmic dust? Is there an edge to the universe, or is that idea itself a trap? Let's begin with what we do know. Right now, our observable universe stretches 46.5 billion light-years in every direction. That's right. While the universe is only 13.8 billion years old, it appears much larger. Why? Because space itself is expanding faster than the speed of light. But here's the catch. When we look into the night sky, we're looking back in time. Light from distant galaxies takes billions of years to reach us. And the further away something is, the older the image we see. So when we talk about seeing the universe, we're really seeing a shell of ancient light, an illusion wrapped in time. We're not seeing what's there now, but what was there billions of years ago. And beyond this glowing shell of information is darkness, a limit, a boundary, but not a wall. This edge, the farthest point light can reach us, is known as the particle horizon. Beyond it, the universe may continue, or not. We just can't know, because light from those regions hasn't had time to reach us. There's also another kind of limit called the event horizon. This boundary is a little different. It represents the farthest distance from which anything we do, like send a signal, could ever reach another part of the universe. Beyond this horizon, galaxies are receding so fast due to cosmic expansion that no message, not even at light speed, could ever catch up. And then, there's the Hubble horizon, the theoretical limit beyond which the expansion of space carries galaxies away faster than light can travel. It's not that these galaxies are moving through space at impossible speeds, it's that space itself is stretching. Each of these boundaries paints a slightly different picture. But they all share one haunting message. We are surrounded by limits, spherical shells of light and information beyond which we cannot see, interact, or even influence. Now here's where it gets truly fascinating. Even though light can't reach us from beyond the cosmic horizon, there are other messengers, subtle, elusive, and powerful. Take the neutrino, for example. These ghostly particles, almost massless and rarely interacting with matter, can travel across the universe unimpeded. Born from nuclear reactions in stars and supernovae, neutrinos can offer glimpses into corners of the cosmos even light can't reach. And then there are gravitational waves, ripples in the fabric of space-time itself. These waves are born when massive objects like black holes collide. In 2016, humanity heard the universe for the first time, not through light, but through soundless vibration. That collision happened 1.3 billion light-years away, and yet we felt it here. These are our tools, our keys, to peer beyond the veil. But let's fast forward. What does the future hold? Because the universe is not just expanding, it's accelerating. Driven by the mysterious force we call dark energy, galaxies are moving apart faster and faster. Over time, this means more galaxies will cross beyond our event horizon, forever lost to us. In fact, one day, trillions of years from now, only the closest galaxies in our local group will remain visible. Everything else will vanish from sight. The universe will become a cold, silent place, wrapped in darkness. The skies will no longer glitter with stars, and we will be alone in a shrinking bubble of light. This fate is known as the cosmic event horizon collapse, the idea that our view of the universe will contract, even as the universe continues to expand. So, what lies beyond the edge of the universe? The truth is, we don't yet have a definitive answer, but cosmologists and physicists have put forward several bold, fascinating theories, each attempting to address this mystery from a different angle. One possibility is that the universe is truly infinite. In this view, there is no edge, only a limit to what we can see, defined by the speed of light and the age of the universe. We are surrounded by a cosmic horizon. The furthest distance light has traveled since the Big Bang, but the universe itself may extend endlessly beyond that horizon. Galaxies could continue forever, beyond our reach, in all directions. Another idea suggests that we live in a bubble universe, just one among a vast collection of other bubbles. This is the essence of the multiverse theory. Some versions of the multiverse arise from inflationary theory, where regions of space stop inflating at different times, forming isolated bubble universes. Others emerge from string theory, where multiple dimensions give rise to separate branes or sheets of reality, each hosting its own universe. These other universes could have different physical constants, perhaps no gravity, no light, or even no matter at all. Some may resemble ours. Others might be totally alien. And if this is true, then beyond the edge of our universe might not be emptiness. It might be another universe entirely. Then there's the concept of a cyclical universe, or what some call the Big Bounce. This theory suggests that the universe goes through endless cycles of birth, expansion, collapse, and rebirth. After expanding for billions of years, gravity or some other force could eventually reverse this process, causing the universe to contract back into a singular point. That point could trigger another Big Bang, starting the cycle over again. In this model, what lies beyond our universe could be a previous universe, one that collapsed to give rise to ours. Finally, some theories propose that the universe has no edge at all, not because it's infinite, but because it's curved in higher dimensions. Like how you can walk endlessly around the surface of a sphere without encountering a boundary, the universe might loop back on itself in a four-dimensional space. If you traveled in a perfectly straight line far enough, you might end up back where you started, without ever hitting a wall or falling off an edge. Each of these theories opens the door to new questions, and that's what makes them so powerful. They remind us that the universe is far stranger and far more beautiful than we've ever dared to imagine. But even within the universe, there are mysteries that suggest something strange is going on. Take the Boötes Void, a region of space so empty it defies logic. It spans 330 million light-years, yet contains almost no galaxies. It's as if something carved out a hole in the universe's fabric. Then there's the Eridanus supervoid, which coincides with a cold spot in the cosmic microwave background, the afterglow of the Big Bang. Some scientists think this void could be evidence of a collision with another universe. Are these voids random, or are they clues, breadcrumbs left by something beyond? And now, we face the ultimate mystery. Not what's beyond space, but what's beyond time. What came before the Big Bang? Some physicists say the question itself makes no sense. Time began at the Big Bang. There was no before. Others, however, propose intriguing theories. The no-boundary proposal, Stephen Hawking, suggests that time itself may be curved and finite, with no beginning, just like how Earth has no edge. The Big Bounce theory imagines a previous universe collapsing before rebounding into ours. Loop quantum gravity describes a quantum bridge between a contracting universe and ours, removing the singularity altogether. And yes, some speculate our universe could be born inside a black hole from another universe entirely. Here's the irony of it all. We began by asking, what's beyond the edge of the universe? But maybe there is no edge, no wall, no finish line. Maybe the edge is not a place, but a transition, a moment, a turning point between what we can see and what we still don't understand. Maybe the end is just another beginning, a doorway to another cycle, another world, another version of us. So, what lies beyond the universe? We don't know. Not yet. But every time we look deeper into the cosmos, we peel back another layer, a veil of light, a curtain of time. And maybe, just maybe, we'll find that the edge we feared was simply the start of something even grander. So here's the real question. If there is no edge, where does it all begin? If you're curious about how time itself might end, or whether the multiverse theory could explain your very existence, click on the next video right here. The journey through the vast unknown has only just begun.